Hey guys, let's start. So, did you all go through the lectures that I suggested? The reading materials for linked lists? Okay, nice. So, I will just give a quick 1 minute, 2 minute thing like how linked list will work, and then we will start right into the questions. If you have any doubts, please like unmute yourself and speak. I won't be able to look at the chat all the time. Okay, so linked list. So as the name suggests, it's a list which is formed by a lot of links. That is a linked list. Visually, how we say a linked list is, you have one item and it links to the next place where the item is stored, which again links to the next place where item is stored, so on and so forth, all the way. And the last nodes links to a null value, and we denote null as this, right? So important thing to notice is like not all the values are stored contiguously in memory, unlike in array. In array, say you declare a 4 byte array of size say 8, then 32 bytes of contiguous memory is so say this is at address 5, then this will be at address 37. It will be all the way till 37. So 32 bytes are contiguously stored, but over here in linked list, say you have eight nodes in the linked list. This can be in address 5. This could be in address 71. This can again be in address 34, so on and so forth. And this could be in address like some anywhere in XF, anywhere in the computer, anywhere in the memory where the RAM finds space to keep it. So traversing array is always faster than traversing the linked list, because first you need to get the address, then go to that address, then access the value, so on and so forth. But insertions and deletions in linked list is faster, because you can just add one thing over here, or if I tell you to add something at here, it will take you order one time. While in insertions and deletions, strictly speaking, in arrays, so when we say arrays, we believe the size of the array will be fixed. So you need to create a new array, and which takes order of n time. So that's the advantage of array. That's the advantage of linked list over array, right? Quickly, how do we represent linked list in C++ or C? So let's say if you want to do a struct representation, then I will say type def struct, and we call this as a node of the linked list. So I will represent one node, and then there will be a value over here, and then there is a pointer to the next element. So let's say we have a double value. So we say double of val, and since it points to the next node of itself, so we have struct node star. PTR. Generally, we call this as a next pointer, so I'm just writing it as a next, and that's it. This is how you define the node of the linked list. The place where linked list starts, we call this as the head of the linked list, and this is the next pointer for the current node. So this is the basics. Like, any questions till here? Okay, so I'll use a code sharing to share what all problems we will do today. and you can copy and paste problems from there. So the first problem we are going to do, that we are going to do is remove nth node from the end of the linked list. It's a medium problem. It's problem number 19. Think about it for 5 minutes and then we will start. In the meantime, if you have any solution, like you can speak up as well.
So I have a small doubt.
Yes.
Can you explain the difference between the dot operator and the arrow operator? Like sometimes to access elements of a structure, we use the dot operator, but in linked list, we've been using the arrow operator.
Yes, so whenever you are accessing via pointer, you need to use a dot arrow operator. So say this I called node, right? And this is how I define my structure. Now say I define a variable node star a, right? So what is an a? A is a pointer to that node, right? Like where the value is stored. So since a is a pointer, we say a arrow val and a arrow next. But if I dereference a, the way to dereference a is using star a. So star a will give me the contents. So if I do star a, then I can use star a dot value and star a dot next. That's the only thing. That's when you do arrow and dot, nothing else. Is this clear?
Yes, sir.
Okay. Okay, guys, any solutions, any suggestions how we can do this? And like these are pretty simple problems. We will, like, depending on the pace of the class, I will move to tougher and tougher problems. So like if you guys have any solutions, please don't hold it to yourself. Let me know and I can move fairly quickly.
So first we traverse the linked list and find the length of the linked list.
Okay.
Then we remove the length minus n element from the first index, from the start of the linked list.
Okay, yeah, that is one way of doing it. Any other solution? Any other solution?
So we could use two pointers, one the fast pointer and one other a slow pointer, and we take the loop. We what we do is i- we we move the fast, like we take a loop from 0 to n, the n will be an input, and we increase the fast to the end of the nth element, so that slow pointer will be n elements behind the fast pointer. And then if we check, like if if we have reached the end, the like we'll create a loop that fast dot next is not equal to null till it reaches, we keep on increasing fast to fast dot next and slow to slow dot next. And once we reach the end, we'll remove the slow pointer to we'll change the slow dot next to slow dot next dot next. Do I make sense?
Slow dot next dot next.
Like we'll remove, like, did you get what I
Twice,
said?
twice, what you're saying. Okay,
So
that is for removal. Okay. So yes, that is a solution. So in first solution, we are going to traverse linked list twice. And in the second solution, we are going to travel linked list only once. So just to elaborate what the second solution is, we will maintain 2 pointers, not fast and slow. And the initial positions of 2 pointers will have an offset of length n. So let me just rephrase it, what someone just said. So say this is the nth node from the end. Never mind, this is an n node from the beginning. This is the nth node from the end, and this is the end. So the length of this is n. You know that, right? Initially, we will have 2 pointers, P1 and P2, that points over here. And it says since remove nth node, what we will do for initial setup, we will move P1 n steps forward so that it points to the nth pointer from the starting. That is the initial setting that we did. And then we will run a loop, and in each iteration, when we increase P2 to P2 arrow next, we will also increase P1 to P1 arrow next. So think of it like when P1 hops over here, P2 also hops over, like in the same page. So in that sense, it is not slow and fast, but it is at the same speed that the 2 pointers hops. So when P2 reaches the end, right, then P1 will reach the length minus n part. So this is also length minus n part. So P1 will reach over here, and then we can delete that node, right? Any questions, concerns?
Sir,
Is this
but
clear?
deleting twice in first method.
Pardon?
Why you are deleting twice in first method?
I'm not deleting twice in first method. I'm saying that this
Like
entire question will take 2 times, traversing the list 2 times. Once you need to find the length, and then you again need to go to the nth element to delete it, right? So twice is not for deletion, but twice is for the entire operation. You traverse it twice. But in the second solution, we will traverse the entire linked list only once. Is this clear? Any other questions? Let's quickly code this just to start off. So basic semantics or syntax that I always keep in mind while coding linked lists is do null checks in these beginning, because you often get into segmentation fault or null point exception, things like that. So this is the base case, like when head is null or head arrow next is null, then you just return. Then you maintain 2 pointers. So I will say P1 P1 will point to the head of the list, and initially P2 will also start P2 will also point to the head of the list, right? And then I will add a loop which runs till end part, right? Also, like there could be a case where the length of the linked list is less than n. So we say that P2 is not equal to none. That's another check that we need to add. And we say plus plus I. And then we say P2
So, but it
is
says n will always be valid.
okay. Okay, but it's always good to have checks. So I agree what you're saying. So this is that's how you move P2 to n steps forward. Now, like say the length of the linked list is exactly n, then we need to delete the first node. So we will say that if P2 is null, that means it has reached the end of the list. So the first node is to be deleted. So I will just return P1 arrow next, because it will not give me the pointer to the head node, but it will give me the pointer one right to the head node, the next node, right? And then we will have a loop, and we will say while P2 arrow next is not equal to null, we say P1 is equal to P1 arrow next, and P2 is equal to P2 arrow next. That's the only loop we will have, right? And then we will say that what are we going, how are we going to delete it?
We will assign the value of it to null value.
So P1 arrow next will be equal to P1 arrow next. That's the simple deletion operation that we will have. This will remove the nth node, and then we will return the head of the linked list. Is this part clear to everyone? So let's say that 3, 4, and 5, and I want to delete 4, and like there are other linked lists as well, and then there is 12 and this points to null. Now I want to delete 4, and P1 is pointing to 3, right? So P1 arrow next. So the value that P1 arrow next will point to will be equal to the value that its next pointer is pointing to. So P1 arrow next is 4, and that's next is 5. So I am saying that P1 arrow next should point to the value 5. So that's what I'm writing over here. So after this deletion, it will be something like 3 arrow 5 dot 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 12 arrow null. And once everything is deleted, once the nth node is deleted, we will return the head of the list. Let's run this. Okay. Right. Any questions? Something that was not clear? Okay, so let's move to the next problem, odd even linked list. It's problem number 328. So if you guys have any solution, please speak up.
So we could have a node pointing to the first node, sorry, a pointer pointing to the first node and then the next node. And
Hmm.
each time we can increase this by 2, each of them. So we can traverse this way.
But how exactly will you traverse? I'm not certain I understand. So what is your time complex space complexity?
So we'll have to create a new list for this. So it will be a node.
Okay, so let's do it with order 1 space complexity. So one is create new list. Two pointers for traversal. One is for odd and one is for even, right? This is what you're saying. So the space complexity for this is order n, and time complexity is also order n. So what I want is space as order 1 and time as order n. Any other solution? I'll give you 1 more minute and then I will start. Okay, let's start. One way So way I would like to imagine is that you are given some linked list, right? So this is odd 1, odd 2, odd 3, so on and so forth. And this is even 1, even 2, so on and so forth. Like how I would like to do this, I want to decouple this linked list. I want to delink and relink this list in a such a way that the issue never arises. I would essentially want to create this list initially, odd n, and then even 1, even 2, all the way till even n, and then I will append the whatever is needed. I will append like odd still to the even, and that's how it's done, right? So I will just modify the existing list so that this points to this, even points to this, odd points to that, so on and so forth, right? Now performing operations or thinking about it, like using the original list to do operations could be tough and it could be non-intuitive. Like how are you going to traverse it, and then how are you going to delink it and relink it again? What if like once I delink it, my reference to the next pointer is gone, then I have to maintain that as well. So there are too many variables and too many complications involved. So the way I think about is, the way I want to think about it is, we create two lists, two dummy nodes. So remember, we are not actually creating new list, but we are creating just two dummy nodes. One, we say that it will have even, and another we will say it will have all the odd nodes, right? And the even will, so the dummy list for even will have initial value of 0 and will point to null, and odd node dummy will also have initial value of 0 and point to null, right? And then as we traverse through this linked list, we will add values to this even node, and then we will add values to this odd node, and after that we will start linking everything else. So this actually, we are think of it like we are creating two new lists by initially creating two dummy variables, and then we are modifying the new list as per the criteria requirement of the question, and then we are doing post processing operations to get the final result. So this way, thinking in this way helps a lot. Like, think like I'm creating a new list. We will come to some other examples, like how will you reverse a linked list. So there are very really complicated ways to do that. But like, if you think like I will just create a dummy node and then I will solve my problem, the problem becomes pretty simple to solve, right? So over here, what I will do is I will have 4 variables, like just to go in more depth. So one will be odd head, second is odd tail, then third will be even head, and fourth will be even tail, right? And as the name suggests, it is pretty obvious, like odd head will point to the head of the odd linked list, and odd tail will point to the tail of the odd linked list. Even head will point to the head of the even linked list, and tail will point to the tail of even linked list. And then as we progress, we will have one more pointer, the current pointer, which points to the current node. And as we progress, we will determine that which list to put in. So if we are at the odd iteration, we will put it in the odd list. If we are in the even iteration, we'll put it in the even linked list. So is the solution clear? Like how we are going to do it? Okay, so let's start. So odd head will be same as head predefined. Yes. Yes, Sakshi. Odd head will be same as head predefined in the structure. So let's notes. Then why taking another pointer? What is your question exactly? I did not get your question. Sakshi, I'm waiting for your question. So let me, like, you can unmute yourself and ask. We'll start. Why do we have to use a dummy node? So that's just a thought concept. If we use a dummy node, then like solving it will become pretty easy, because then your brain will work only towards working that how I'm going to fill the dummy nodes. So the implementation would be really simple. Say, see down. If head and odd head are both same, then what's the need of taking two pointer for same pointer? because say the, okay, so that's something that we should clear out. So like head is not any other variable, it's a reserved variable which explicitly points where your linked list begins, right? So this will always point where your linked list will begins. If you do head is equal to head arrow next, if you iterate through head, right? So now head will point to this one. Then you don't know the address for the first one, right? Now this is completely gone and there is no way to retrieve it. It's not like array that you just point to an index. If you do a of 1 or a of I, then you can go to the ith index, but then you can also do a of 0 and then you can go to the first index. But in case of linked list, if you move your head ahead, say head is over here, then all these values are gone. It's completely gone, because how do we define a linked list from the head of the linked list, right? So if I just give you the value, like I just give you the head pointer, you only know what is there to the right of the head pointer, like what all value it points to, but you never know like what is it being pointed from. So that's why we always reserve head to be at the beginning of the linked list and we don't miss this, because that's the only source of truth that we have, right? We will create dummy variables and we will use that. So don't get confused with arrays or things like that. Once you lose the reference, you lose it forever. Use of 4 variables. Sure. So initially that we said that we will have 2 lists, one to track all the odd nodes and another one to track all the even nodes, right? So for odd nodes, I'm defining 2 variables, odd head and odd tail. And for even node, we are defining 2 variables, even head and even tail. Now, odd head will point to the head of the odd linked list and odd tail will point to the tail of the odd linked list. Even head will point to the head of the event linked list and even tail will point to the tail of event linked list. That is the invariant that I have in the question. This rule will always follow whenever I'm coding. Is that clear, Karan?
So we need only the odd tail and the even head, right? Or like we need only 2 variables, right? Why do we need both?
What do you mean?
Like to link both of them, we'll need the tail of one and the head of other, right?
Yes, but while creating the linked list, you need the tail, right? How will you create the linked list in the first place? Shashank, right? Shashank, you will be speaking?
Yeah.
Yeah. Is there something I'm not understanding or some other or a better way you're suggesting?
No, like I didn't fully understand.
Which
the
part
approach.
exactly? Why do we need tail?
Yeah, like why 4 variables?
So how would you do it? Like let's discuss, like, so you are given this linked list and how are you going to do it? So how many variables do you require?
Okay.
Odd tail and even head. That's what you're saying, right?
Yeah, okay. Got it. Like just to create the linked list, we need the heads. That's what you're saying, right?
You need only the heads, you don't need the tails. Is that what you're saying?
No. Like if you want to just create the 2 linked lists to append, that's when we need the heads, and you need the tails to link both of them. That's what you are
Yeah.
saying, right?
Tails is not needed to link both of them. Tails is needed to create the new list, to track the progress of the linked list. So
We
as we
give an example, like run
yes.
through.
So say this is the linked list 1, 2, 3, 4, 5. Right, and right now I have a temporary, or let's say we have a current variable which points to the head of the linked list, right? And there is a dummy node for odd. which initially has a value of 0 and it is null. And then there is a dummy node for even, which has an initial value of 0 and which is null. Right now, current, we know that it is pointing at an odd index. So we will say that odd head will always point to the start and even head will always point to the start. But once the current index is at 1, then we say that append it to the odd head. So now this odd will be appended and then odd tail will point to the end of the index. Odd tail will point to 1. Okay. Odd tail points to 1, right? Now when current goes to the next value, 2 is an even index, so we will add 2 over here, and even tail will point to 2, right? Now when 3 comes, we say that 3 is an odd index, so from odd tail, we know where odd tail is pointing to, and we will append 3 over here. And we'll point this to null, and then odd tail will also point to 3. Similarly, when 4 comes, we know where even tail is pointing to, so we will add 4 over here. And then even tail will point to 4, so on and so forth. So this even tail and odd tail, they are always at the end of the linked list. As and when the variables are coming, we are storing the last known value and using that to add other values as well to the list. Is this clear?
Yeah.
Okay. Any other questions? Okay, so if someone who has already solved this question, I will just give you another question as well. Do this one, merge case ordered list. It's question number 23. And in the meantime, I'm going to do this odd head star even head. So I'm saying that I'm just creating a new list. So the way to do this is new list node, and we say it's the value 0. Even head will say it's a new list node, and the value is 0 initially. So I'm creating 2 dummy variables, and then I have 2 tails. So odd tail will initially point to odd head, and even tail will point to even head, right? I will also have a dummy variable, let's say current, which points to the head of the list. So remember, we never want to mess with the head of the list, and we will have a variable is odd. So this variable will denote that the current, whether the current head, the current list we are looking at, or the current node we are looking at, whether it's at index odd index or is it at even index from the start. So since current is looking at the first head initially, so is odd is also true. Now we will loop through the list. Well, okay, quick check in the beginning. We will say that if head is null, or head arrow next is null, you return head, don't do anything. And then over here we say while cur is not equal to null, then if it is pointing at the odd position, then we will say that append it to the odd tail. So since cur will be pointing to the next one, so we say this, and we then say odd tail is, we increment odd tail by 1. So we say odd tail is equal to odd tail arrow next. That is very similar to the example that we were doing. Else, if it is at even, it's pointing to the even position, we will say even tail arrow next is equal to current and then even tail is equal to even tail arrow next, right? So this is done. Now we will also increment current by to the next pointer. So we say current is equal to current arrow next, right? Or tail is points to the null. The next pointer for dot tail will be null, and next pointer for event tail will also be null, right? Also, one more thing, we'll switch the gears. We say odd is equal to not of is odd. So now the next time it will be an even, and again the next time it will be odd. Once everything is done, we have two lists. One only contains the odd, and another only contains the even. So we say odd tail arrow next is even head arrow next. So we append even to the end. So we are saying that even head was the dummy node. So we don't want to append the dummy node, but we want to append the next to the dummy node from where the actual linked list begins. That's why we do this over here. And then we say return odd head arrow next. It's as simple as that. Any questions? Okay, so this worked correctly. Okay, this also worked. Any questions or things you did not understand? So the core crux is just to just think that we are creating a new list, create variables, how many so ever much variables you need for that new list, and then do the operations. Once you have a purview that a new list is created, you just return the new list. So these kind of questions will be very common. So it's odd even linked list. Then there could be a question like reverse the linked list. So that's why also you can think that, okay, I need to create a new list, so on and so forth. So thinking in that direction helps a lot. Moving on to the next question, merge case sorted list. Let's like give it it's a tough question, so give it like 5 minutes and then we are going to solve it. So line 28. Yes, this one. So let's say initially odd is true, right? And cur is pointing to the head. Now we went into the loop. We did all this thing. I hope you get this part. And then we are saying that cur is cur arrow next. So now we are moving to the next value, right? So when odd is true, then you are putting it in the odd list, right? Now when cur moves to the next part, then we say that we need to put it into the even list, right? So we say that odd is not of is odd. So not of true will be false, right? So one, if it enters the loop again, then is odd is false, then it will append to the even linked list. Again, curve will point to the next node, right? And then again odd will be true, so on and so forth. So it's like a switching mechanism. Like think of it as a bit variable, z, which is 1 initially, and then you are doing 0 and then a 1, 0 and then a 1, just to keep track. Okay, so think about this question. If you're not able to think about it, like a quick hint I will give is we will use merge sort over here. That's a really big hint. So you guys have done merge sort, right? I assume. You have not done merge sort? Okay. Okay, so we won't do this question then. Let's skip it. We did a merge function in sorting. So haven't you done like divide and conquer for sorting algorithm? Like
So we
you
did not do merge sort, but we did merging the intervals.
okay, have you done recursion? Okay, so you should be good. So brief overview, like, okay, so this will also help you to understand merge sort. It's a good problem to have then. So let's say you have an array A1, A2, A3, so on and so forth. A of n by 2, A of n by 2 plus 1, so on and so forth, and A of n, right? This is the array, right? And then you want to sort this array. What we do is we take the first half of the array. We say in the recursion, we say, okay, you sort this one separately, and then you sort the remaining array separately, right? Once these two arrays are sorted, so let's say A1 is after sorting this, and A2 is also after sorting this. Once these two arrays are sorted, you merge these two arrays. So once you merge these two arrays, since these two arrays are sorted, merging will always take order n operation to get the final array A1, which is like some interleaving of A1 and A2, right? So you interleave A1 and A2 together, so on and so forth. And then you return the value of A. So that is exactly what merge sort does, right? And since it's a recursive problem, we say that, okay, now my sub problem is you want to sort this one. So you again divide this array into two parts. You give A11 and then A12, and you sort them independently. And after sorting it, you get A1 after sorting. Similarly, you would do it for A2. Like you process first half of the array to sort independently and second half of the array to sort independently. So that essentially what merge sort is. Let's go straight in the problem, like because I guess it would be tough for you to understand. So it says merge k list, right? So one thing to remember is all the k lists are sorted, right? So you have L1, L2, all the way through Lk, and L1 has some values 1, 3, 5. L2 has some values 2, 4, 6. And Lk will also have some values 11, 21, 37, so on and so forth, right? So what we will do is we want to merge this list into a single list L, so that it contains the sorted value like 1, 2, 3, 6, then 11, then there could be some other values in between as well, 21, all the way till the end, till it ends. So this is what we want to do, right? Like okay, you guys can give me a brute force solution, right? Or how are you going to do it in a brute force way? So let's reduce the scope of the problem, and let's say you have only two lists, 1, 3, 5, and 2, 4, 6. So how would you merge these two lists in a sorted way? Guys, please unmute yourself and answer this. Like,
So we can have two pointers, and then both the pointers start on the first element of both the lists, and then whichever is minimum we start with that, and then if we have already used, then we increment that pointer, like it goes to the next element.
yes. Yes, exactly. So now say you have K list, right? So 1, 2, 3, 4, all the way till K. Now, how are you going to do this then? By brute force merge L1, L2 similarly in pairs, then merge the resultant in pairs. Okay, so what she's saying is you merge this one, you get L12, and then you do L12 and L3. So you merge these two, so you get L123. Then with L123, you merge the next list. So you merge all these three, all fours together, so you'll get L1, 2, 3, 4. You do so on and so forth until you get the final list. Yeah, so that's one brute force way of doing it. That I agree. Right. Also, another brute force way is you can have K pointers, right? Since you are given K list, so by default you're already given pointers to the K heads. What you can do is at every iteration, you loop through all the variables, check out the minimum variable, say 1 is the minimum variable. You create a new list, like merged list. Let's say I'm creating a new list, say merged list. And merged list then will point to 1, right? And then you increment the pointer 1 by the value of 1, like you increment this to the next pointer. Again, you will check all the heads of the K list. We see 2 as minimum. So now we add 2 and then we increment value of this over here, right? Now again we check, we see 3 is the minimum. There are contradictions. So let's say I pick this 3. So I add 3 to the end of the list and then I increment this pointer. Again we check, we see 4 as minimum, and suppose I pick this 4 right now. So I will add 4 over here and I will move pointer to the next element. Say next element is 7, 9, so on and so forth. That's how there are K pointers every time. I'm looping through the values of the K pointers and I'm creating my new list over here. So, and then we are getting one list in the end. So that's a way. Can someone tell me what will be the complexity for this? Let's say you have K lists and the average length of each list is n. So what will be the complexity?
K times n.
Yes, okay. Order nk is the complexity for this algorithm.
Is it given that all K of the lists are sorted individually?
Yes, it is given, right? Merge K sorted lists. That, okay, this is sorted. Yes, that is given. So is this part clear? How are we going to do it? Now let's look at a bit advanced way. So we know that we need to do merging and things like that, right? So let's say that now you have list 1, list 2, list 3, list 4. For example, let's say only take 5 lists. What we will say is we will merge these lists independently. We will merge these 3 lists independently. And then the resulting value that we get, we will merge the resulting value. But now it begs the question, how are we going to merge the 3 lists? right? So then we say that split it into the half. We say that I will merge these two lists independently, and I will merge L3, which is trivial because you don't need, there is no op over here. And based on the final value, I will merge the list. So say this is L12 and this is L3. Then I merge these two lists and I get L123. Now L123 is over here, right? And for L456 also, we do the same thing. L4 and L5, we merge both of them together to get L45. And then for L6, this is essentially a no op. So I merge these two guys together and I get L456. So L123 is over here and L456 is over here, right? Finally, I will merge these two lists and I'll get the final linked list L, right? Suppose like there was 12 nodes in the linked list, say L7, L8, L9, so on and so forth till L12. What would we have done was, we would have said that I would merge the first part of the linked list independently, first half of the list of linked list independently, and second half of the list of linked list independently, right? And then I will merge these two lists again. So let's say this was L first and this was L second. So then the final list is the merging, interleaving of these two lists, right? To get the final list. How I am going to do merging for this list is the same way I described over here right now. So this is the like overall concept how we are going to do this. So there, what we need to do is at every iteration, we will divide the list into half. So there are 12 nodes, we will divide into the first 6 and next 6. And once there are 6 nodes, we will divide into first 3 and next 3. If there are initially first 11 nodes, then we can divide in 5 and 4 and then 5. So if there are 11 nodes, we will divide it into 5 and 4. 5 we can divide it into 3 and 2, and 4 we can divide it into 2 and 2, and 3 we can divide it into 2 and 1. So merge these two. Okay. 1 minute. Merge two lists over here, get one list over here, then merge these two lists over here, get one list over here. Then similarly, you will get one list over here, and then you merge these two lists to get one list over here. And over here, you also do a same repetition. Is this part clear? Like guys, can you act once if this is not clear how we are doing it? Or anything, because this is very crucial, and this is essentially what merge sort does. Not really, it's not the same. Says Sriram, which part exactly you did not get it? Can you point it out? This part? So I'm saying that initially we had said that we had like forget about the second one. Initially we had said that if we only had six list of linked list, then how we are going to do a merge operation. Was that part clear? Okay. So now I'm saying, like, suppose you have a new question where you have 12 linked lists. So let's say you have a new question for 12 linked lists, right? L1, L2, all the way till L6, L7, L8, and all the way till L12, right? Now, since you have 12 linked lists, how are you going to solve it? So I'm saying, okay, you divide this problem into first half, solve it for the first 6 linked list, solve it for the next 6 linked list, right? Because you know how to solve it for linked list of size 6, right? So once you have the solution, what the solution will contain, it will contain merge the sorted list when you merge all the 6 linked lists. That is the solution that you get from here. Similarly, same idea can be applied over here. Once you sort this list based on the previous operation, you get LS. What is LS? LS is the sorted list for all the 6 linked lists over here. So once you have two lists over here, then you can do a simple merge operation on these two lists, right? LFS. And this will give you a solution for the 12 list of size 12. Is this part clear? How is it better than brute force? So in brute force, what we are doing is, let's say the example that we took, 135 and 246, right? So we are creating a list of size 6, right? And then the complexity wise, the number of comparisons will be less over here. It will be like logarithmic of number of merge operations is same as is same. Not exactly, I would say. So this will go beyond the scope of the problem. Like I thought you knew merge sort, but we can there would be heavy maths involved, and it could be shown that the complexity will be n of log k. But I guess we will take some other session for this. Just remember that once you do the merge sort algorithm, when you merge, when you use merge sort algorithm to sort some array, then order is always n log n. It's not n square. And this is the exact algorithm we are deploying for merge sort over here as well. So for that, we need to look into the time complexity. Do you know Master's theorem? Okay. So I guess this is the beyond the scope for this current problem. We will have some other session, or I will ask Sankit to set up another sessions explicitly for merge sort. And then we can discuss the nuances and details for this as well, like why this is a much better and efficient algorithm versus merging it. Okay.
So
Yeah. Yes.
So the complexity will be same even if the lists were not sorted, right?
But then the question does not make sense, right?
No, so actually I wanted to ask, is there some other way we can actually take the sorted lists to our advantage? Because
but how are you going to do merge of two lists if they're not sorted? I don't know. So that's how we are taking sorted list to our advantage. We are breaking it into fewer parts, and we are saying that the resultant is also sorted, and then we are using it to sort the bigger list.
okay, sir.
Okay. So let's quickly code this thing. So I would recommend you guys, after going back, go through merge sort algorithm once, because that will really help. Because I've literally done merge sort with you right now. So let's say, let's define another function. Let's node star merge. We have the starting, the end index, and we have a vector of list node star ampersand lists. So what this function will do is, from index start to index end, it will merge all the list. Like this is a list of vector, and list contains from index 0 to index n, and merge says I want to merge only a subset of the list, which is from the start till the end, right? So how are we going to do it? A few examples, like a few base cases would be, so this is a recursive function. So base cases will be, if start is more than end, then we cannot merge, you return null. If start is equal to end, then we say you just return the first value, which is list of start. If start is more than end, then we need to divide this interval into two parts. How are we going to divide the interval? Guys? So we want to find the midpoint of these two intervals. Can someone speak up? Yes. So basically, we will say that int m is start plus n minus start. I like to do like this to avoid overflow, right? And then once you get the mid value, so let's say this was 0 and this was 6. So you got the mid value, which is 3. Then you create two lists, say L1, and you say you merge this list independently. So you say start to mid and then list, and then you do it for L2 as well. For L2, I will say that merge it from M to N, all the list, right? So once these two lists are merged, you have a bigger list, right? So I will just return a new interleave function. So I just want to interleave merge. Let's say I want to call this, and I will pass L1 and L2 over here, which will interleave the two functions, the two lists together. So now the question remains to add that interleave function. So over here, quick base cases will be if L1 is null, then return L2. Oops. And if L2 is null, then you return L1. These are the base cases. Then we say that if L1 arrow val is less than L2 arrow val, then L1 should come first and then L2. Then we say, okay, we will have L1 arrow next is interleave merge, because the value of L1 will stay and value of L1 will not stay. So we say that we will move the value of L1 to the next pointer, and we say interleave these two variables. So again, I'm calling a recursive function on top of interleave merge. Else I will say L2 arrow next, since value of L2 is less, interleave merge L1 comma L2 arrow next. Merges two lists. Yes. Okay. So one thing is I return L1 over here. And once this is merged, I will return L2. So that's how we merge two lists. So let's say we have two lists, 1, 2, 3, and 4, 5, 6, right? Or 1, 3, 5, and 2, 4, 6 over here. Then none of them are null, but 1 is less than 2. So we say that, okay, we will keep 1 and we will merge 3, 5 and 2, 4, 6 together, right? So in the next loop, we will have 3, 5 over here and 2, 4, 6 over here. And that's how we will do interleaving operations. And we will merge the entire list. So what is the base call that we need to make over here? Can someone answer?
So we only need to call the merge function.
Okay, with what variables?
Variables starting should be 0, ending should be the size of lists.
Okay.
And lists.
Okay, yeah.
Yeah, -1. Yes, right.
So is this part clear to everyone?
And sir, in the list nodes, shouldn't the merge be from M to M plus 1?
Oh, that's right. That is absolutely right. Could be that the cause of error. Yes, that was the error. Okay, so this is done. So guys, like, please go and study merge sort, like, and it will help. Let's move on to the next question. It's reverse nodes in K groups. So question number 25, and I'll just copy this over here. Think about it for 5 minutes. I'll be right back. Okay, guys, let's start. Any ideas? Guys, okay, can someone say how just to reverse a linked list, how we are going to do that? So this is a precursor to this problem. So say I have linked list 1, 2, 3, then null. I want to return the reverse linked list will return 3 to 1 and again null. Use 3 pointers method. That's tough. Okay, so today I gave you some hints, right? Always think that I will create a new list and create a dummy node. Then how are you going to do that? Okay, so way to do this is you just create a dummy node, say new node. So this is just a dummy node, right? It contains value 0 and it points to null. And then you have an iterator on the first list, say cur. That is how we did the odd even problem as well. Now when cur is at the first node, we just say that, okay, append cur over here. So we say, okay, add 1 over here and move cur to the next node. So now cur points to 2, right? We say the cur 2 should come in between 0 and 1. So we will say, okay, point from this, go to 2 and then you go to 1 again. So now the dummy node stays as it is, and then we do 0 and 1. Again, the cur points to third node, and then we say, okay, third should come between the head and the new node. So it comes to 3, which again comes to 2, and which again comes to 1. And that's how and then you return the pointer head arrow next, this one. So this gives you a new list, which is reverse. So I generally prefer doing this way. It is much simpler and neat. And 3-pointer, you need to do checks, then you previous, then current, then next. So it becomes like too much effort, and space wise as well, it takes the same time. You just need one extra variable over here, and in 3-pointers you need 3 variables. So okay, get the length is called length of the list. Then we know we need to perform L upon K groups of reverse operations. In each group, reverse is performed for K minus 1 times. Yes. So did everyone got like how are we going to reverse a linked list? Like, is this part clear? Like this is the precursor to the problem. Guys, please act no act. Clear? This one is clear. Okay. So let's quickly code this thing. I believe that this should be there. We need to check. Reverse linked list. So this is an easy problem, right? So over here I say list node star new head is equal to new list node of 0, right? Oops, sorry. And then we say while head is not equal to null, list node star 10 is equal to head arrow next, new head arrow next is equal to head, I guess, and then head arrow next is equal to new head arrow next, and then we say head is equal to 10, and then we just return new head arrow next, and this should work. So essentially what we are doing over here is, just to give you an idea, say this is my list 1 2 3 4 5, right? And my new head, which is a dummy node over here, so 0, right? And until now I've done like 2 and 1 has already been reversed, right? So now my head points to the third node. So once my head points to the third node, I'm saying, okay, let the temp value be head arrow next. Let me write it down over here. Head points to third node, then temp will point to head arrow next, which is the fourth node, right? And then we say that new head arrow next is new head arrow next, right? So third's next value will be new head's next value. So new head arrow next is 2, right? So the next value that her third will point to is 2 now. So we are creating a link where 3 will point to 2. So when I'm doing that line, I'm doing 3 will point to 2, which will point to 1. That is what I'm doing. So head arrow next is new head arrow next. Now we are saying that why new is written before list node. That's how we define, like, that's how we define it. So that's the syntax for C++ Vidyut. So 3 to 1, and then we say new head arrow next now points to the head. So now it will be new head of 0, it points to 3 to 1. And also head right now it points to 3 to 1. Head also points to 3. So we say now head will point to temp. What is temp? Temp points to 4. You can try Vidyut. I don't think that will work, but you can definitely try that. So now head will point to 4 right now, which is this value over here. So that's how we are doing it. We are not taking extra space or things like that. Okay, so this is done, right? Okay, I should have copied that. I'll just copy this function. This will be useful. So now we know that we can reverse k nodes in linked list, right? So we have this reverse function. Let's call it reverse. That is easy. Now let's get back to the drawing board. What are the options that we have now? Now we know that we can reverse linked list. Now we want to reverse it in groups, right? So now the idea is pretty simple. Say that this is of size k. Not like this. Ignore this one. Say you have a list 1, 2, 3, so on and so forth. 7, 9, 41, 108, and this stands right. Now you have this big linked list and you want to reverse in groups. So I define my groups like this. We know that we have these k groups present and we need to reverse this, right? So essentially the idea is you reverse this part and again then you reverse this part, then again you reverse this part, you reverse this part, and if it is less than k you don't reverse it, you keep it as it is, and then you link these lists together. Now the complexity lies in the fact that how are you, once you reverse this thing, right, the link to the next node is broken. So that's where like the complexity lies in the problem, that's very crucial to solve. To make it very easy, what we are going to do is we will call it a recursive function. So when we say that you want to reverse k groups, so it is as good as you reverse the first k and you call the entire operation on the next k group function. So this will be as simple as that. So reverse k groups on linked list of size L is equivalent to reverse first k and then you call reverse K group on remaining one. L prime, where L prime is all the elements after removing the first K elements. So you check, like you count the number of elements. If it is K, then you pass it to a reverse function. So more detailed algorithm is you have this linked list, so on and so forth. You have a current pointer, and you move the current pointer until you get a value of, like, until this distance is K. Once this distance is K, then you reverse this part completely, and then you call function on this, the recursive function, to reverse K group on the remaining one. So then you don't need to bother about the pointers and things like that. Things will work out magically on its own. Once you reverse this, the only thing you need to keep in mind is the header pointer and the tail pointer. That's the only thing that is required. If you have the tail pointer, you can link the tail pointer to the result that you get, and the header pointer is what you will return as the final output, the pointer to the first variable, right? If it is clear, like, we will code it real quick. If something is not clear, please let me know. So let's say we want to reverse K groups. So we will say, okay, there is one more variable, autocur, which automatically assumes, like, it dereferences what you're trying to talk about over here. So this comes in handy all the time. And then we first loop through the first K values. And also we do cur is equal to cur arrow next. So we say that if not of cur, if cur is null essentially, then you return head, because you cannot reverse this section of linked list. Else what you say, you once you are out of this, then you want to reverse, like, so once you are out of this, then you have head points to the beginning of the list, and cur will point at K distance ahead of head. Now we want to reverse that particular section, right? Now in this list reverse, we have only the head. So let's also add, like, list node star last, the last variable that you want to reverse, right? And the only change we will have is while head is not equal to last, I guess. That's the only change we want. Like, until it is not last, you do the reversal. Once you reach the end, then you would return the reversed list. So this will give you pointer to the new head. So you say auto new head is reverse head comma cur, and then once you do this, now head will point to the tail of the new linked list. So suppose you had 1, 2, 3 over here, and you call the reverse function. Then after reversal, you call reverse. After reversal, it will be 3, 2, 1. And initially head was pointing to 1. So head is also, right now it is also pointing to 1. So we know that the value of head is the new tail that you have right now. And that is what we want to link to the next list. We will say that reverse K group. So what are the parameters that we are going to pass over here? Can anyone tell? Guys?
Card next and K.
So what? Cur?
Card next and K.
Why cur next? So remember, when it breaks out of the loop, it already points to the next variable. So we say cur and k, that is what we will say. And then we return the new head. So when I'm calling the reverse, then I'm reversing one just to the left of it and not the entire thing. If it is the last, then I don't reverse it. So this is done. Okay. So what's the use of auto? You don't want to write list node star all the time. So auto C++11 or C++, some version of C++ it provides to use auto function. So like if you have really complicated data structure like map of int of string and a vector, and which then again has a set, you don't want to type the what type is the variable, so you just type it auto and the compiler compiles it for you. So that eases a lot of things. So wherever I have written list node star, I can always write auto and the compiler will figure out itself. Is this clear to everyone? Like how the reverse in K groups is working? So it looks like we have done this as well. Let's move to stacks, a bit of stacks today, because I don't think we will have time. Let's open this one question. So we will look at simplified path. So this is question number 71. I'll just remove this for once. And think about it. So how many guys don't know what stack is? Let me just quickly give you an overview. Okay, let's quickly give an overview. So there are other couple of questions in linked list, but I think we have done a lot of questions on linked list today, so I'm deferring it for the next day. We will do it the next day. Let's look at an easy problem for today. So stack is a data structure, just like linked list. And it has, as the name suggests, it has a property that you can only stack up values in it. So what paradigm it follows, generally we call stack as a LIFO kind of data structure. Now LIFO means last in, first out. The last value that you push into the stack is the first value you can only retrieve from the stack. A way to analyze it is like you have a stack and you're pushing numbers. So you have a stream of numbers 3, 7, 8, 2, 9, 1. These are all a stream of numbers that you are getting. Then you can push 3 in, and then say, and you're looking at the stack from here, right? So you can only look at the top element of the stack. You can't look at any other element. So once you push 3, you can look at 3. Once you push 7, you can only look at 7, but you cannot look at 3 now, right? Once you push 8, you can only look at 8, but you cannot look at 7 and 3. So on and so forth. So let's say what is the first value that I can only retrieve? I can only retrieve 8. So I can, so what we say is stack dot peak. So you're peaking for the top value, or they also say top value. What is the top value of the stack? So this will give me, right now both of these will give me value of 8, right? And another operation that you can do is dot pop operation. So you want to remove from the stack. So this gets removed. Once this gets removed, then you have only 7 available. So this will get removed. Now you have only 7 available. Again, if you do a peak or top, then you can see here 7. Now, say suppose you want to push 2. So another operation is push, and you want to specify what you want to push. So push and the variable name that you want to push. So you can push 2. Now, if you do a peak or a top, then you will get a value of 2 as the answer. So you cannot traverse through stack. The only way you can traverse through stack is only you can see the top element. You can push any element to the top. And if you want to traverse, you need to pop it out of the stack, and that is gone forever. That is then never persisted. So the last value in is the first value that gets out. So that's why it's called the LIFO data structure. So this is the simple concept of stack. In C++, the template to define stack is stack. And what kind of stack do you want to define? You can define an int stack. So that's how we define in C++. If you want to define a long stack, you say stack of long and S. And you can define stack of custom data types as well. You can define stack of some list node star as well. So this is stack of all the pointers that points to list node. So on and so forth. And then the operations that you can do over here is s.push, s.pop, and s.top. These are the 3 operations that you can do on stack. So this is pretty much it, the basics of stack. Anything which is not clear over here? Okay. So let's look at this question. Simplify path, number 71. Okay, I added it over here. Think about it for a minute. So one more thing, like when we do a recursive calls, right? So recursive calls are also like computer program, they maintain their own stack. So we say function stack, right? Or print stack trace. So it prints in the recursive fashion, like function 1 called f function 2, and then function 2 called function 3, so on and so forth. So that is maintained in the stack as well. How the call is going on. Okay, like if you guys have any solution, like you can speak up. So here are some examples. Look at. Any solutions, any suggestions? Anyone? So if you have any idea, you can speak your idea as well. Like this is how it should not be restricted to stack, but any idea that you can think of, 2 pointers or recursion or things like that. You can speak your mind out. Guys, Okay, so let's discuss this. Are the questions too easy or like, what do you guys think? So over here you are given like, you do this, right? You change directory. Then you say that /home /var /logs. Okay, I don't wanted to go into logs, so you do dot dot. Then you say opt. You go to libexec. So you made some mistake, so you did dot dot, right? So on and so forth. Now, again you did a dot dot over here. There's two single dots over here, and then there is a double dot over here. Again you do a double dot, so on and so forth, and you finally go to your home directory. That's where you landed. So this is like traversing this entire thing is non-optimal, because once you're going in and then you're coming back out. So what is the most optimal path that you would want to take? That's the entire question. So a quick demo. So you will go to home directory, then you go to var, then you go to log, then you say, okay, come out of log. Double dot means come out of log. So you say, okay, I don't want to go to log. So where do you want to go? You say, go to opt, go to libexec. Two dots means, okay, stay at libexec. Then you again do a two dots. Then you say that, okay, I don't want to go to libexec. So you cancel this. So where do you want to go? You again do a two dots. So you say, I also don't want to go to OPT. Okay, you cancel this. Where do you want to go to? I want to go to SP, right? So it says go to SP. So the final path is /home /var /sb. Now the input, your input will be this string over here, and you want to output this, right? So if you look at problem carefully, the idea is very much how to simulate a stack. If you are going in, go in, go in, go in. If you encounter a double dot, come out of it. Again, try to go in, go in, go in. If you encounter a single dot, don't do anything. If you encounter a double dot, come out, come out, come out. And again, you go to SB. So how are we going to simulate in stack? You write home over here. You write var over here. So the invariant that stack will maintain is the most optimal path till now that is to be visited. So this is the invariant of the stack. Anything that is in the stack is the most optimal path to reach that particular place, right? So home var log, and you're picking the top of the stack. If you see a double dot is there, then you do pop this thing out of the stack. So now this becomes the most optimal path, right? Then you again input OPT over here. You input libexec over here. You see dot dot, okay, you don't do anything, but again you see double dot. So you say, okay, remove libexec. Again you see double dots, you say remove OPT as well. Then you see SB. So finally you put SB over here in the stack, right? And then you, as you come out, you pop things out of the stack. So you pop SB first, then you pop var first, and then you pop home. Why you removed the log? Because there was a double dot over here. So double dot means go back one directory up. Right? Double dot means going one directory up. Single dot means staying as in where you are, so on and so forth. Okay, cool. So this is a very simple simulation of stack. I will go to coding part, and that's it. This is how to use the stack. So we will say that stack of string stk. Let's call a stack as values stk. Now, one thing is we want to delimit this based on forward slashes. So we use string stream. So what string stream does it? It's a inbuilt variable provided by C++. Data type, and it takes in the string and it converts it to a stream or string, and then you can apply delimit operations on the string of stream. So when I say that get line on SS on like TMP and some variable this, then what it does is it splits SS based on forward slashes, and then as many times I do a get line, it will populate it in the temp string. So this is the input string where I want to get my result in at, right? So let's say if I specify a string temp and I say do this get line, and initially let's say I have this example over here, right? So this is the example I have. So it will split the string. So how the split will be of some form this, there will be nothing over here, \0 and then foo. When I do get line for the first time, then temp will contain the value of home. When I do get line for the second time, temp will contain value of \0, and when I do get line for the third time, temp will contain the value foo, right? So every time I need to do a get line on string stream. So I just add it as a while loop. While this is, and once this ends, it returns a null value. So you know that you need to exit out of the loop. So we say while you are getting non-zero values, then there are few checks that you need to do. So if temp is equal to empty or temp contains a single dot, then you say that okay, there is no path to be optimized, you hit the continue button. Or else if you say if temp is double dot and stack is not empty, so how do we check the emptiness of stack? We say if temp is okay, I should not have done that. So if temp is double dot, then we say okay, we need to move one place up, then we do stack.pop. Now it doesn't make sense to do stack.pop on an empty stack, so we add one more constraint over here. We say while not stack is empty. So it will only pop when the stack is empty, else it won't pop. Else if temp, if double dot is there, if double dot is not there, then we say that okay, you push into the stack the value temp, because that's a valid qualifier that we want to push, right? So once this is done, so based on criteria, either it will push into the stack or it will pop out of the stack, so on and so forth. And then we need to create a final result, so we'll say string result, and then we say while stack is not empty, you want to pop it out of the stack. So I say result, and you want to add a delimiter / everywhere because we removed it while doing a get line. You do stack.pop and then you add your result towards it. Okay, there should be stack.top, not pop. After getting the result, you do stack.pop as well. Right? And then you return result over here. So one thing to note is that result could be empty set. Like you can do /home /. So this is an empty set, right? So result will if I do this, then stack will be empty. So result will also be empty. But it says that forward slash should be done if nothing is present. Note written must always begin with a forward slash. So over here, I have a quick check, like if result is empty, then you return forward slash, or else you return the result. That's the only check that we have over here. Any questions regarding the coding part or things you did not understand?
Sir, the condition of the first while loop, can you explain it again?
This one?
Yes.
So you have done this stream, right? So it gives you a stream of string, and then when you say get line on the string of stream, it asks like how do you want to. By default, it will use \n for delimiter, right? So let's say this is present in stream, like slash home slash foo slash a slash b, and then there is a \n present, and again something else is present. Something else is present, so on and so forth. So when you say delimit using forward slashes, because that's the requirement of the question, so it splits the string based on only forward slashes, right? So what this does is you want to get the line from the string stream using forward slash as your delimiter, right? And where do you want to put the result? I want to put the result in temp. So this is exactly what it is saying. So for example, I'm looking at this one. So it says, this is my string stream, use forward slash for my delimiter and get me the first line. So if I use forward slash as the delimiter, then my first line will be home, right? So get the home and put it in the temp variable. And once home is there in the temp variable, I'm checking it over here. Again, if I do get line on string stream, so now my string stream gets reduced to this part. Now again, in the next while loop, I say get me a line from the string stream SS using forward slash delimiter and put it in the temp. So it will scan the string. Once it finds the forward slash, it will remove everything and it will give you this. Like it won't remove everything, it will keep this in its stream, but it will return this as the value. So this gets into the temp. And again you get A, again you get B, so on and so forth. Is that clear?
Yes, sir.
Now in example 3, there are 2 consecutive forward slashes. So in that case, it will return an empty string and it will exit the file.
No, it won't return empty string, right? So the empty string, there's a special reserved character \0 that comes in. Not even \0, I guess. There will be some other variable. What it puts an empty string over here in temp. That's why we have this condition. If temp is empty or temp contains a single dot. So definitely by default it has end of file. That is the constraint that it has, string stream. Once it reaches to the end of the file, it throws an error and it breaks out of the loop. So is this clear? Let's submit this. So that is done. Okay, cool. So what I'm going to do for the next class is, tomorrow's class, I will give you the list of questions beforehand, like what we are planning to solve and discuss. This will give you some time to think about it on your own. And I guess in that way, the class will be much more interactive. I guess like 5 minutes or 10 minutes is not sufficient time to think about a solution and propose an idea. But if you're given sufficient time, you can think about it. So does that help, or like should we continue the way we are doing it right now?
So it will be better if you send the questions.
Okay, so I will do that only. So I will post you a list of questions, and then we can have a vote, like which questions you want me to solve and which questions you don't want me to solve. And then we can continue the next class like that, so that everyone is engaged in that class. Also, you can come up with your own ideas and we can discuss your ideas. Please repeat the 2 slashes. There is nothing there. If you have a 2/ and you say you split the string based on 2 slashes, then this is what you get is a empty string. It's essentially \0, and \0 is kept in the temp. So \0 says that nothing is there. So that's why we have this constraint over here if temp is empty or temp is equal to this. Okay, so that's it for today. Like, any questions, concerns, doubts? If you don't have any questions, like we can dismiss the class for today, and I will share the link of questions. I will send the doc file, and that's what I have planned to do. And you can also go through the questions and you can solve it on your own. And like, just give it like 10-15 minutes. It's not like a homework assignment where you need to code everything. Just think about us the way, like, ultimately being a good coder is about thinking about the problem, because C++ and other things, they are just language to implement. But the critical part is, how do you think about the problem and how do you think about the corner cases or the cases where it will fail. So I would encourage you to just to think about the problems. Once you have thought of an algorithm, just think about the cases where it can fail or where it can pass. And one thing you should always reason is, if it pass, then why will it pass? Like, reason about it, like just try to prove it on your own. And that will give you sufficient confidence while dealing with tough problems as we proceed. Because once we go to, like, once Ankit sir teaches dynamic programming and greedy, it will be more about proving that your algorithm is correct. So it's always better to develop this habit from here as well. Okay. I will share the questions with you. Any questions for me? Okay. So I will end the meeting for now and we will see you guys tomorrow.
Thank you, sir.
Sir, regarding the string function, is that a part of the string class, or where do we read about that? जो string stream जो दिए
तो मैं क्या करता था कि मैं Stack Overflow देखता था, like, so the concept is similar. I want to split a string based on some delimiter. That's the entire concept, right? That will ease my problem. So you just Google in Stack Overflow, like, how do you split a string based on delimiter? And that's how you get articles. Like, in Google, you get articles, so you can use string stream. There are other ways as well. Input string stream, other ways to split it. So from there, you get to know about all these things as well. It's not that I went through the entire docs of C++. So it's based on more on experience, I would say. Okay, cool. See you guys tomorrow. Bye.